Good evening, everyone. My name is Tumatri Reddy. Currently, I'm pursuing my fourth year at SRM University AP with Big Data Analytics as my specialization. The reason why I'm doing this presentation is based on for my information retrieval project, and the project which I'm working on is RAD and their advanced concepts. So to just start off with, before moving on to the advanced concepts, let us first understand what exactly is RAD. RAG is RAG stands for Retrieval Augmented Generation, which is an AI framework that will optimize the output of a large language models by connecting it to external data sources before generating a response. So, to just before moving on to RAG, let us have a question: Why RAG? Why not an LLM? There are two major problems with respect to LLM. The first one is LLM hallucination. So, for example, let us take an example that we train the LLM until the year of 2023. And suppose it is 2025 currently. And if we ask any query like, who won the T20 World Cup in 2024? The LLM doesn't know the exact answer because it is trained up to the date of 2023. The LLM will generate a response to the user specifying that it is correct, but actually it isn't. So this problem is called as LLM hallucination. And the other one is, as you can see over here, it is the outdated knowledge. It is trained just up to a specific period of time. So how does RAD overcome these obstacles? So to see over here, we will initially we'll be connecting our external data sources with the LLM application. So, for example, if I'm starting an organization, a company, and I'll store my data, all my employees' data in a database. So, I don't want any of the outside users of the company to access my internal data. And at the same time, I want to use LLM. RAG will try to help us in such situations. We'll be merging um, RAG, we'll be merging our database with the LLM, and then we'll be fine tuning it. So, because of due to that, the outside users cannot use the private the company's details. So, due to that, it becomes a security aspect for the company as well. So, if we want to get any real-time data, for example, if we want to, let's take the previous example, like up to 2023, our LLM is trained. In 2024, I asked a question like, who won the T20 World Cup? So, RAG has a concept that it will even search in the web. It will even search in the external databases like what the users have given attached their data sources to, and also it will also search in the LLM. Based on that, it will give a relevance score, which has the highest relevance score. Based on that, it will be generating the output. To just start off with, let us see the architecture of RAG. Here initially, um, we'll be storing the content in a vector database, the original content, and also we can keep on adding out the new content to the vector database. So, unlike a traditional database where we store in the form of rows or columns or in the format of JSON, the vector database stores the data in the form of vectors. Vectors are nothing but they are a numerical set of numbers which will hold a semantic meaning for corresponding vector. Initially, vector database, the information will be getting stored with the vector database. And when a user files a query, um, there is a framework, and through that framework, what the query that user has given, even that will be converted into a vector. What query the user has given, even it will be converted into a vector, and it will have uh, a vector representation. And what and with that, we'll be comparing with user's query, and we'll be comparing with um, that vector with the vectors that we have in the vector database. So there will be data retrieved. So that contextual data is being sent along with a prompt. Now, what is that prompt? That prompt is nothing but how we need to generate our output. How, in which format do we need to generate that output? So, before, now at the time of going to LLM, there will be multiple answers generated. So, what LLM does is, um, LLM finds the relevant score. There will be relevant score like what are the relevant documents, how much relevant is this information to the user's query. Now, LLM will be comparing and sorting with the relevant score. And with that relevant score, it will be fetching out um, uh, the top K answers, the top K responses to the user's query. And now the LLM will be sending an output through, before sending an output, it will do a task like post processing. That means it will be converting that into a particular format of the output, and then it will be sending out the response to the user with the top K responses that we got from the output. So this is how the system components are the user query, what the users ask. The embedder, it will convert the query into the vector numerical representation. The vector database holds the embeddings. The retriever will search for the top K most relevant elements, and the LLM generator will generate an answer using the retrieve dots along with the prompt sent by the user, and then it will deal with the response to the user. So now coming on to the advanced concepts, the topics which I'm going to cover is on GraphRag and Agentic RAG. So these are the two advanced topics which I came forward to. So to just start off with, let's start with a GraphRag. So GraphRag is a type of RAG, and it is an advanced evolution of traditional RAG technique. Its purpose is designed to enhance Gen AI systems for its accuracy or be it reliability or its understanding. So, this RAG graph basically works on the concept of knowledge graphs. So, graph RAG stores not just the information, but also it will store the relationships between different entities as well. So, the key advantage is a graph structure allows the system to build richer context by understanding how the facts are linked to each other. So due to that, the output will be even more accurate. And this is mainly used for queries, which have a deep understanding, where we generally require a deep understanding of the user queries to that of the output generated responses. So there is a question when there is RAG, why these different types of RAGs? Because we have seen, we are currently seeing what is draft RAG, and then we'll see what is agentic RAG. So, what are the limitations of RAG? So, how are we just overcoming that? So, to just find out the limitations of RAG, initially, the documents are split into isolated chunks for a better search. So this causes only to see the partial details when we retrieve the response for any query. So due to that, the surrounding context is getting lost, and the retrieve information is not complete. And whenever we perform semantic search, it fails to link the related ideas across different sections or different documents. It finds the partial information or it finds the keywords, just the keywords, and it will retrieve the information. And since it doesn't understand the links between the fetched, the retrieved information, it doesn't explain how they are linked each other. So it is a drawback which states that lack of explainability. So, for example, let us see how they are different, how traditional RAG is different from agentic RAG. So, let us say that the user is given a query, how is the pandemic connected to food shortage supplies? So, traditional RAG gives us an example like pandemic affects the health systems, they lockdown, restrict movements, food shortages can happen due to supply chains. These are correct examples, but there can be even more deeper insight for this query. So let us see how a draft RAD can overcome this obstacle. There is a pandemic, and due to the pandemic, there is a lockdown happening. And due to that lockdown, there is a labor shortage. So due to that labor shortage, there will be reduced farming and reduced production. And due to that lockdown, also there will be some transport restrictions. So due to that restrictions, there will be a transportation disruption. So due to that, there will be a low production. So due to that low production, um, there will be a low shortage of food. So due to that, there is food shortage. So this is how DraftRad shows the relationships and links the relationship between one entity to other entity. So this helps us to show the deeper insight. So as I mentioned, DraftRad works typically based on knowledge graphs. So let us know what exactly is a knowledge graph. A knowledge graph represents the information through interconnected entities and relationships. Generally, the entities means the nodes. In graph, we generally have nodes and edges. Here, nodes are nothing but the entities, and the edges are nothing but the relationship between the entities. So, in RAG system, the knowledge graph acts as a dynamic memory layer, storing the complex information. This structured memory complements the LLM like summarization and extraction by providing deep and relational context. So, enhanced contextual retrieval. Knowledge graphs are queried using languages like Cypher or GQL, which enable pattern-based traversal across connected information. In GraphRAD, these queries combine graph traversal with vector search to retrieve meaningful contextual neighborhoods, significantly, which can boost the accuracy and the relevance of the AI retrieval. So, how does GraphRAD improve the retrieval um, output accuracy? So, as you can see over here, GraphRAD it doesn't isolate the chunks. By using the graph knowledge, it will be exploring the connections. It finds the relevant starting points and then follows a meaningful relationships between the data, gather the deeper information, and then provide richer context than what the traditional RAG does. So, based on this deeper insight, there is a higher relevance. Um, there is a higher relevance to what the LLM will be generating. um, the relevance score will be pretty high. And due to that, the context to what the user has asked a question will be very similar. So let us understand the pipeline of RAG. So as you can see over here, there is a question which is nothing but the user's query. And this user's query, it is being sent to an encoder. And what the role of this encoder is, it will be converting the user's query to a vector. Vector is nothing but which stores the numerical representation of a query and it holds a semantic meaning. So initially there is a graph database present over here at the bottom level. As you can see over here, there are two databases. One is a lexical database graph and the other one is a domain graph. The lexical graph represents the relationships between the words and the documents. So it helps us to find the relevant text passages. While coming on to the domain graph, it represents relationship between the entities. So because of that, it retrieves the structured knowledge and the connections. And these both are connected to a search. The lexical graph is connected to a search and a search plus pattern match. Um, Here, there will be different types of pattern matches like graph ride, or we should go with the agentic ride. So, in the context which we are talking is about graph ride, we'll be using a graph ride pattern match for this particular one. And for the domain graph, we'll be using the graphs, a search plus a pattern, and along with that, we'll be given a query. So, the output which we currently have over here, it will be sent a tool selection The tool selection can be the pattern matching or a graph query or any other combination of these. Um, One of the tool selection technique can be either a keyword-based search, which we can search the pattern. So there are multiple options, and this is being sent into a context. It will identify the context, and then it will be sent into an LLM. Now, along with that query, we'll be given an instruction like how we should be fetching out the data. And along with that, we'll be sending out the query directly to the LLM. So at the LLM, we have the user query, we have the instruction, like how it should be, uh, how the retrieved information should look like, and the context of the information. So the LLM will be built here at this tool selection stage. We'll be building a graph knowledge system. From that, we'll be generating the context, and then it will be sent to an LLM. Now, the responsibility of the LLM is to gather the topically relevant information, and then it will be generating an output to the user in the form of an answer. So let us see that with the help of an example. Like here we have a question like who are the key researchers in renewable energy and their major contributions. Here the data is directly being sent to to an LLM, and we have an encoder which does which converts a query into a vector embedding into a vector, and then it follows it to a tool selection like what we have discussed earlier. From then there are multiple options like search plus pattern search, and it builds the and thereafter it will build a context builder, and then it will be sent to an LLM, and then the LLM, as I mentioned earlier, LLM will find the top relevant score, and then it will be generating out the output. So the real world use cases can be legal and compliance, which analyzes laws, contracts, and regularization for risk and policy checks. It studies companies and people and market trends for informed financial decisions. Which generally require a deeper insight about the understanding of the user's prompt with that of the external database to what we have acquired the query with, and then connecting soil database for unified organizational intelligence, revealing hidden relationships and patterns across large data sources, powering smarter knowledge and aware chatbots and search experiences. So this is all about the draft RAG. Now coming on to the agentic RAG. Agentic RAG is a dynamic framework where an AI agent actively manages the information retrieval process, integrating RAG as its tool within its overall reasoning workflow. So when there is RAG, then why do we use agentic RAG? So the first one, the AI agent actively refines its own queries using reasoning before giving the retrieve output to the user, and also it manages the context and information over time, allowing it to adapt much better to the changing situations. It is well suited for asynchronous tasks where there are multiple steps of querying and multiple steps of reasoning, and it really helps in in-depth research in complex summarization and for complex tasks. So before understanding it, let us go through the pipeline of agentic RAG. So initially, the user will fire a query, uh, will give a query to the LLM. And through this LLM, there is an agent interface through which we'll be sending out a query. And from that onwards, we will be sending out this query into a query analyzer. Now, the role of the query analyzer is that it breaks down the user's query into what is being asked and what is the type of information that is being required and what method should be used to retrieve this information. So after that, this analyzed query is being sent into a task orchestrator. The role of this task orchestrator is that it divides the overall query into smaller subtasks like what information is getting retrieved, um, analyze the retrieved information, generate an initial answer, or refine the answer if it is necessary. So after that, it is being sent into a retrieve planner. The retrieve planner determines how to collect necessary information by deciding what keywords to use and what sources to access the data, and which retrieval method is best suited for the user's given query. So the retrieval planner will determine these sort of things. And after that, the retrieval planner will be going into the information retriever. So this module will execute the retrieval plan and fetches the relevant data and chunks from the vector database using semantic search. Now, after going through this, um, we'll how this information is getting retrieved is through the vector database. It will do a semantic search. It will retrieve the data and it will be sending out the data to information retriever. And the information retriever, um, it will be sending out the retrieved information into the context assembler. Now, the role of this context assembler is that it will collect and organize the retrieved information, remove the irrelevant and the noisy data. And after performing this task, this will be sent to an LLM generator. Now, the role of this LLM generator is to create an initial draft of the answer, and after that, the generated response will be sent to a response evaluator. Now, the response evaluator will be responsible for testing out the quality of the data and checking the reliability of the generated response. Like, is this information accurate? Um, does it contain any hallucination? And should any additional data be fetched? Now, after that, it will be if there is if the response evaluator thinks that still the information needs to be refined, it will be sending out a feedback to the task orchestrator, and the task orchestrator will be performing the same thing over and over again until the response evaluator thinks the answer is reliable. So if the answer is reliable, it will be sending out a final response to the response refiner, and that response refiner will be sent to an agent interface, and that agent interface will be sending out will be showing out the response to the user. So this is how the typical RAG pipeline looks like. It is iterative, it is multi-component, which uses reasoning at multiple stages to manage the task. So as I mentioned, as I explained, this is the workflow of the agentic RAG. Um, it has an agent interface which will receive the query. The query analyzer and the task orchestrator breaks down the task into a task breakdown and retrieval strategy. The retrieve planner and the information retriever intelligently decides what to retrieve and fetch the relevant context chunks from the vector database. The context assembler and the LLM generator create a preliminary response. The response evaluator judges the quality, and then the response refiner, using the feedback, can send the task back to the new retrieval cycle or refine the answer before delivering the final answer to the user. So this is how a typical agentic RAG pipeline looks like. So coming on to the use cases of agentic RAG, it is used for research automation used for academic or market research. It is used in AI coding assistance like in debugging, whether to search the documents or even to refine the code iteratively. It is being used in medical knowledge assistant like retrieve clinical information, verify the guidelines, and verifies the advices. It is being used in financial analysis and reporting, like gathering the markets and analyzing the trends, and then drafting out the reports. It is being used in autonomous research bots, like browsing the web, collecting up the facts, evaluate the sources, and then produce the summaries. So this is how agentic RAG is being used. So that's all about it. Thank you.